Hello, physics fam. We are rocking out acceleration problems. Let's take a look at number 2 of our worksheet to see if we can start better understanding these types. So it says Ms. Borse is driving her car with an acceleration of 4.3 meters per second squared. So in my guess method given to me, it looks like I'm given 4.3 meters per second squared as one of my pieces of info. I'm going to put an A for acceleration. It says it takes her 14 seconds to reach her velocity. 14 seconds to me is an amount of time. I'm going to write that down just in case. And it says to reach her velocity from rest. So if she started from rest, I can assume she started at 0 meters per second for her initial velocity. It says, what is her final velocity? So that looks like what I'm solving for, final velocity. Now in my guess method, E is the equation I'm going to use. We know it's very new to us, but we're going to do final velocity minus the starting initial velocity divided by time. And I feel like I can do that. I can start substituting and plugging in for some of those variables. For A, which is acceleration, I can put 4.3. For my velocity final, I don't know what that's going to be yet, so I'm going to solve for that. For my initial velocity, over here, I've got 0 meters per second, so I'm just going to subtract 0. And for time, which is at the bottom, I have 14 seconds. So let me go ahead and start doing some work to finish this up. First of all, subtracting 0, that's already gone. So now I just need to get rid of this 14 so I can get VF, or velocity final, by itself. So to get rid of 14, I'm going to multiply 14 to both sides. 14 is going to cancel out. And now that I do that, I should have velocity final by myself is equal to 14 times 4.3. If I multiply those together, 14 times 4.3, I should end up with a number of about 60.2, and that is going to be in units of meters per second. So that ended up being my answer there. But take a look, did you plug into your equation right, and did you use proper algebra to solve for it? Taking a look at the next, number 3, Baldy is walking quickly after Sandy. He starts from rest, okay, so right away given to me, my starting initial velocity is 0 meters per second. And he then attains a velocity of 1.23 meters per second. So that looks like Baldy's final velocity is 1.23 meters per second, which is pretty quick when you're in a Baldy costume. Nice job, Baldy. Now, if his acceleration is 3.2 meters per second squared, so that's given to me. Acceleration is 3.2 meters per second squared. I want to know how long does it take to reach this final velocity. So that looks like how long something takes is really asking me what the time is. Perfect. So now that I'm given all that information, I'm going to see what equation I can use. And I know the equation that not only solves for acceleration, but includes velocity initial, final, and time. That is the acceleration equation. Velocity final minus velocity initial divided by the time. So I think I'm ready to plug in for my S, my substitution. Let me change my color. I'm going to go with green. For my acceleration, A, that's going to be 3.2. For my final velocity, VF, which is right here, it's going to be 1.23. For my initial velocity, it's 0, so subtract 0, and then divided by T for time. Now that I have that, the nice thing is that minus 0, gets canceled out. So it's really just 3.2 equals 1.23 times T. So to solve that, we have T in the denominator. Let's get T into the numerator. So I'm going to multiply both sides by T. By doing that, this T cancels out, and I'm left with T times 3.2 equals 1.23. Now that I have T, I'm going to get it alone by dividing by 3.2 to both sides. 3.2 cancels out, so that's going to be T equals 1.23 divided by 3.2 and I end up getting 0.38 seconds for my answer. There you go. Rocking the equation, feeling good. The way to go. Rocking out number 4, a cheetah is running at a velocity of 8.23 meters per second. All right, so that is a velocity. I honestly don't know from reading so far if that's my starting velocity or my final velocity. But that's okay, I can add that in once I figure it out, but I know it's a velocity. So the cheetah's running, sees lunch, and speeds up to 10.45 meters per second. So that must mean if it speeds up, it's afterwards. So that must be my final velocity. So 10.45 meters per second. This must be my initial velocity. And we do that in 5.45 seconds, which is time. So there we go, 5.45 seconds is the time. And I want to know, what is the cheetah's acceleration? So it looks like I'm trying to find A, acceleration. Lucky for us, we know that acceleration incorporates time, velocity final, and velocity initial. So acceleration is equal to the final velocity subtract the initial velocity divided by time. Perfect. S is going to be substitution. So let me start subbing in everything so that I can solve for acceleration. All right, I'm going to keep A by itself because that's what I'm solving for, acceleration. Velocity final up first is 10.45 minus velocity initial, which is right here, 8.23. See how labeling it helps me? It's nice. I keep organized. I'm less likely to make a mistake, divided by time, which is 5.45. And with that in mind, I'm going to get myself a nice little math problem. So first thing, order of operations, I'm going to take 10.45 minus 8.23, get that answer, and then divide by 5.45. And what I end up getting after I bust that through my calculator, I end up getting about 0.41, and don't forget my units are meters per second squared, since this is acceleration. Nice, 0.41 meters per second squared. Way to go, let's crush that last one. Here we go. Number 5, a student is chasing after another student. The student ends up with a velocity of 8.78 meters per second. Again, I know that's a velocity, but so far where I've read, I don't know if that's technically my starting or ending velocity, but I'm okay with that. I'll figure it out. It takes the students 4.5 seconds to get to the speed. All right, so that's telling me it took the time of 4.5 seconds. The student had an acceleration. Ooh, okay, so I've got an A, an acceleration of 2.34 meters per second, which is meters per second squared. I want to know what the student's initial velocity is. So I want to know my starting velocity for this kid, which means that the velocity given must be my final velocity. But now that I have that, I can plug into my equation. Acceleration is equal to velocity final minus velocity initial over time. Perfect. Well, let's do it. I'm going to switch up my color and let's start substituting in. For my A, acceleration, I have 2.34. For my velocity final, I have 8.78. Subtract my velocity initial, which I don't have, so I'm going to leave that as a variable. I'm going to divide by time, which is 4.5 seconds. Now that I have that, you notice that you're subtracting velocity initial. For me, subtracting can sometimes throw me off, so I'm going to turn the minus V1 or VI into plus a negative VI. The reason I'm doing that is so I don't forget about that negative variable. It makes me feel better, but you can leave that alone if you want, but it's the same thing, minus VI or plus a negative VI, but that helps me out a lot. So I'm going to slowly get VI by itself. To do that, I'm going to start by multiplying by 4.5 to both sides. By doing that, 4.5 cancels out, and I'm left with 4.5 times 2.34 equals 8.78 plus a negative VI. Now that I did that, I can multiply these crew together. 4.5 times 2.34, which gives me 10.53, which equals 8.78 plus a negative VI. Now, how do I get VI all alone? I'm going to subtract away from it the 8.78. So let me subtract 8.78 from both sides. That's going to cancel out and leave me with negative VI. And then if I do 10.53 and I subtract from it 8.78, I'm going to end up with 1.75. Now, sometimes we might think that's the answer, but don't forget about this negative on the VI. So, to get rid of the negative on the VI, I'm going to multiply both sides by a -1. By doing that, VI now becomes positive, and 1.75 becomes negative. And since this is a velocity, the unit's going to be in meters per second. So I ended up with an answer of negative 1.75. Well, what the heck does that mean? Well, it means this object is going at a constant velocity, or at least a velocity, but negative means backwards. So this person is moving backwards. And that can happen when you're getting chased. So this person was moving backwards initially and then started moving forwards in order to catch the person. All right, physics fam, way to go. Hopefully we got a little more clarity of plugging into our acceleration equation and also getting more comfortable with our algebraic rules. Way to go and best of luck.